gonna have different shapes that we make. The first one's gonna be called a limicon. So limicons are in the form either r equals a plus or minus b sine of theta, where both a and b are greater than 0, meaning positive. Our second option is r equals a plus or minus b cosine of theta. And then what we're going to look at is is the relationship between a and b less than 1? If that's less than 1, we call it an inner loop limicon, which means that it looks like this. If a over b equals 1, then we call it a cardioid, which looks like pretty much like a heart, but less pointy at the bottom because it's more rounded here. The difference between these is this little loop here. So this one doesn't have the loop and this one does. If a over b is bigger than 1, but less than 2, then we call it a dimple, no inner loop. And the reason that we call it that is this one has a dimple, but not an inner loop. This one pretty much has a dimple too, but it technically has a tiny inner loop that's just 1 point. This one, the difference is that the point where they're meeting is an immediate turnaround. So it's a dimple instead of like on a heart when you draw it, this piece that kind of comes down, it's more rounded. So it's more of like a arched piece, and that's why it's a dimple. This one is much more indented and this one's not. The next one, a over b is greater than or equal to 2. And we say that's no dimple, no inner loop. What that looks like is essentially a circle, but one side of it is pretty flat. Well, it is flat. So it's a circle, but like this piece right here is flat. So what that means is if you're doing the table, these values would all be the same for the radius all the way down. So that's the difference there. Whereas on a normal circle, on this type of graph, the radius is changing all the time. And that's because it's like a trig function. So we're gonna look at those and we're gonna try to determine what is what just based off of the equation. So if it gives me something like, let's see, r equals 1 plus 2 cosine of theta. So I'm in that right form. I'm gonna look at a over b, which a and b, right? So I'm gonna go 1 over 2. That's less than 1. So this is gonna be an inner loop, which means I know it's gonna look like this guy right here. And that's it. I mean, fairly simple. We're just kind of setting it up in that format. The next shape that we're gonna have is a rose. Which roses, they really do look like a flower. Something like, badly drawn, but something like that, okay? So this will be in the form of r equals a sine of n theta. So the difference between these two, this one has something that's being added to it, and also this one has something being multiplied by our theta. So those are the difference. So if n is even, then the petals equal 2 times n. So if it gives me r equals 3 sine of 4 theta. This is an even number. So I'm going to do the number of petals is 2 times that. So it's going to have 8 petals. So 1, 2, 3, 4, 5, 6, 7, 8. Something like that. Okay? If n is odd, the petals just equal n. So if it told me something like r equals 2 sine of 3 theta, then that means it's going to have 3 petals. So it looks something like that. Okay? Although that's not a good representation. It should look more like this. Come on. More like that. Okay? Now, yeah, that's pretty simple. That's pretty straightforward. The next shape is called lemniscates. I don't know. Lemniscate. This one, r is squared. And also, the value in front of your sign is squared. Or in front of your cosine. It doesn't actually have to be squared. It could be 1, but that would mean a is the square root of 1, which is still 1. It could be, let's say, 3, and then a is actually the square root of 3. That makes more sense. So when I have this one, it's going to be symmetric to the pole. So that would look like maybe like this. It's symmetric to here, meaning that these are reflections of each other. And the distance here equals A, which comes from there. So if I did have one that said r squared equals 3 sine of theta, then this value right here would equal the square root of 3. Okay? If I'm using this one, the cosine, it's going to be symmetric to all of the values that we had, to the pole, to the polar axis, and to theta equals pi over 2. So the way that that would look is something like this. It's symmetric here, it's reflected across, it's symmetric here, it's reflected across, and it's symmetric here, it's reflected across. So all of those values would be the same. Not the same, mirror images of each other. So when we're dealing with a cosine, we make it graph this way, and when we're dealing with a sine, we make it graph this way.